Thank you very much for the invitation. It's the first time I'm attending. Maybe I should introduce myself a little. I'm from the, did my PhD at Edinburgh University in the theory of computer science. And my background is type theory, concurrency theory. And I'm doing both concurrency theory, semantics of synchronous programming languages, but also logic as foundations for semantics of programming, specifically concurrent programming. And in this the development of my interest in logic, I'm presenting results that have been presented recently in September this year at the Tableau conference, and jointly with Stefan Scheele and Luke Berg. Stefan, he's here attending. Stefan is a postdoc. He has done a PhD with me a couple of years ago in constructive modal logic. And Luke Berg, he's also attending. He is has just submitted his PhD in computational semantics of natural languages to University College of London. So Stefan, he's at the Fraunhofer Institute research postdoc, and Luke, I say, he's with me here currently, helping me as a teaching assistant. Now, what we are talking about is modalities from a constructive point of view, and the specifics of this is the combination of positive and negative modalities, necessary and possible as the standard positive, and unnecessary, impossible as the complementary negative partners. Technically, we are setting up a constructive modal logic that we call CKD, which stands for constructive K a la Došen, which is a conservative extension of intuitionistic propositional logic that combines all these four modalities in a constructive way. And as I progress, you will understand why that's not so obvious, how that works. The results or the technical development is going on both in model theory and in the proof theory for this system. The model theory is based on birelational cryptograms. The proof theory proceeds in standard Hilbert deduction and against Dragalian multi-conclusion sequent calculus that are equivalent with each other and complement there. Help us to provide results. I will introduce first the playground a bit, motivating the modalities. We will then go into a preliminary presentation of the syntax of the logic and intuitionistic base, cryptosemantics specifically, before we then enter into a more detailed discussion on the problem that we are solving here with the constructive interpretation, which culminates and finishes in the technical presentation of the Hilbert, a bit of it, and the Gensen sequent calculus for this CKD. Finish with conclusion. Well, my introduction is starting from basically philosophical view on modalities. The modalities are not independent of each other, of course, but connected and related along two categorical dimensions, as they say in philosophy. The quantitative aspect of the modalities can be universal or particular, and the qualitative category distinguishes between affirmative statements and negative statements embodied in these modalities. For instance, the necessary statement, something is necessary, which is written with the box, is an affirmative universal claim. The possibility is a affirmative, but a particular claim, hiding an existential in a way. The impossibility comes to sit in northeast corner as a negative universal, and the unnecessary modality would then be in southeast position, a negative particular. Okay, now this modal square for positions, if you take it into classical modal logic, would naturally turn into logical relations in some way. Namely, in the classical modal logic, we interpret the modalities as quantifications over reachable possible worlds, where the box and the impossibility become universal quantifiers, the existential, the possibility, and the unnecessary become existential quantifiers, and the matrix that is quantified is either positive or a negative statement. No? For every reachable world is false would be the impossibility statement that contradicts or that becomes the partner to the necessary. Now, this in classical world is the classical really square of oppositions by Aristotle. And the point is that in classical logic, all of these corners collapse into what can be generated from any one of them. Yeah, along the sides, we have double negation relationships. Possibility, is a double negation of a box. Something is possible if it's not necessarily false. Something is unnecessary if it's not possibly false. If not impossible that it's false, it's unnecessary. And the diagonals are really just taking the negation to move across from a necessary to an unnecessary, or from a possible to the negation impossible. This is classical collapse, I'd say, which is not what we have in a constructive world. In a constructive non-classical logic, the existential and universal quantifiers are not De Morgan duals of each other. Normally, this often corresponds to natural language use of modalities, where the double negation is typically a weaker statement than the straight modality. For instance, let's say down here, if you go to a party, if you're invited to a party and your host says, it's not necessary that you bring flowers, this does not, of course, mean it's unnecessary to bring flowers. Of course you bring flowers, it's necessary, because there's a constructive context that of courtesy that makes it necessary to bring flowers, even though you can consistently maintain at the same time it's not necessary, from in a weaker sense. Well, to make this a little more concrete and technical, to bring up the issue about keeping these modalities distinct in a constructive setting.
May I ask, sorry for interruption.
Yes, please.
A question about notation.
Yes.
It seems to me that it would also be reasonable to denote impossible as box with minus inside.
Yeah.
Because then box would indicate the universality.
Yes.
Of this, and
yes, I'm missing these cases here.
So sort of interchange the other two.
Yeah, true.
Since notationally that's a reasonable choice, but here we read something like, first we read the diamond or square, and then we sort of read the bar or negation, so to say, right? So this is
yes. In classic logic, it doesn't. Yes, both are possible, and in the constructive setting, both cases are different. Whether you put the negation in front of the box, or you put the negation after the box, or you use a negation in front of the diamond, will give you different different modalities. Yeah. That's true. So I'm using this notation with the diamond with a minus inside and the box. I think it comes from Došen, some later work he published in a handbook or some summary papers. Okay. Yes, I forgot to point that out. Well, so let's look at examples that make like concrete scenarios that might that bring home this sort of the issue about constructivity versus classical view of modalities. Imagine a couple, as a little made up, not so serious, but still has serious content kind of example. Call them Romeo and Julia. Juliet, who over and over again have the problem of deciding who is going to wash the clean up the pile of dirty dishes that is accumulating at the side of the sink. And of course, they will maintain, as a specification of the game they are doing, that of course necessarily one of us, necessarily you or me, will have to do it. But at the same time, it's not possibly me, brackets again, that will do it. And she will also maintain, no, it's not possibly me either again. And in addition, we agree that life must go on. Possibly something must happen. And this is perfectly consistent constructively. The situation develops in real life in hundreds of cases, and nothing is really, breaking down. But if you translate this into the classical modal logic, where the negation is classical negation, and you have the dualities, we get in trouble, because not possibly me would be the same as necessarily not me. Similarly, not possibly you would be immediately the same as necessarily not you, which by the rules of, in fact, any kind of logic, classical or constructive, would mean necessarily none of us, which is in blatant conflict with necessarily one of us, which brings the conclusion necessarily deadlock. Necessarily we're going to crash in the discussion about the problem of doing the dishes. Well, that by itself would not be so much of a problem, but we have the existential import. We insist that something must happen, life must go on. So we want to execute this modal step, and then classical logic is just rendering everything inconsistent. No, possibly true, and necessarily bottom will give you possibly bottom, and possibly bottom is the same as bottom. So classical logic will not be able to make sense of the situation at all. It's simply inconsistent. The same happens in a dual way with the negative modalities. If you imagine now the dishes are cleaned up and you want to go to the opera, you have to leave the house through a narrow door. You need to squeeze through that door. And of course, it's impossible for both of us, impossibly both of us, you and me, squeezing through at the same time. But you don't want to give, you want to give up, you want to insist, you don't want to concede. So you insist that it's not unnecessarily me, and also symmetrically not unnecessarily you, with again the assumption that something will happen. The game will produce some result. In the end of the day, this problem is solved all the time in fractions of a second if the communication works. So constructively, no problem. But classically, translate this with classical negation and dualities, you end up in a logical crash, inconsistent, no model, there's no way. Classical logic is abstracting too much. So the modalities of the constructive world are supposed to recover this sort of causality, metastability, or whatever that happens in a more refined view of the world. So much for a basic introduction to constructive modalities, positive as well as negative. Let's move on with the theory a bit and introduce the syntax that will then generate the problem. The syntax of CKD, set of formulas, is well containing the binary connectives, the usual ones, and all the four of the modalities independently, starting from a set of propositional variables, as usual. So equally normal or standard is to view the constant true as an abbreviation with a propositional constant implying itself. A little unusual would be what we do here. We consider the constant bottom as an abbreviation for unnecessarily top. Also truth is unnecessary is the absurd in our system. That's for a little. It makes sense semantically in all of the modal logics that I know, but it's also convenient for me to avoid some axioms later and to be a little symmetric about the rest of the axioms. Negation is in constructive logic is an abbreviation for the formula implying absurdity, and by implication is as usual reduced to implication. Now, I will have occasion to talk about restricted languages, playing with these modalities specifically. So if you choose a subset of modalities, you can consider the set of formulas that in the language that has all the normal logical connectives plus the selected set of modalities. Remember that in my definition, of course, although it's not very important, the fact that we always include the bottom means that we always include that special case of the unnecessary modality, but it's a trivial technical sort of technicality. The other thing we need now is the definition of a theory. We're interested in logical theories, which are subset of formulas relative to some set of modalities. closed under deduction, modus ponens, and uniform substitution in that fragment that we are interested in, focusing on a set of modalities. That's a theory. Right. Now, a difference between classical and a constructive theory is, and that's a definitive feature of constructive logics, as far as I know, the theory we call constructive if it has the disjunction property. Disjunction property says that if the theory contains a disjunction, it must it must decide this disjunction and contain either one or the other of the disjuncts already. That's a pretty strong statement to make, a pretty strong property, because we have to remember that a theory is to be closed under uniform substitution. So substitution of formulas for propositional variables arbitrary. So if you have a disjunction property, and it now requires that if you have a disjunction, which is and then all the substitution instances of disjunction, then you must already have all the substitution instances of one of the disjuncts. And that's a strong statement to make, which is non-trivial, and is a strong coherence, a strong coherence property on a theory, which is not satisfied by classical logic. In classical logic, we know, because of the excluded middle, for even as generically in a propositional variable, we can prove P or not P, contained in the theory if it's closed under uniform substitution. But of course, we cannot prove the P nor the negation of P, because if P would be in the theory, by uniform substitution, every instance of this would be in the theory, so every formula would be true. Or if this is in the theory, then every formula would be false. There's of course, nonsense. It would make the classical logic, a classical logic with exclusion middle and disjunction probably would be trivial. The standard reference logic on which we are now going to build up the modalities in positive and negative form is, of course, the intuitionistic propositional logic, which can be generated from the well-known standard axioms or axiom schemes, which give you introduction and elimination for the operators conjunction, elimination, conjunction, introduction, disjunction, introduction, disjunction, elimination. All of these axioms are perfectly constructive in the sense that the proofs, you can imagine the proofs are lambda terms that implement these formulas as types, transforming proofs according to the introducing and eliminating constructors for the operators. And we close these axioms under modus ponens. The IPL would then, in this setting, be the set of all formulas without modal operators in the empty language of modalities that can be generated from these in this Hilbert system. Okay, now this is standard, and we know that this is a constructive theory, so it satisfies the disjunction property. So that's the baseline, is well known. We are not going to extend, so this is the proof theory that we extend. We also need to look at the semantics, Kripke semantics that can be used to explain these axioms, because we are going to derive our theory from looking at the semantics, as you will see in a moment. The intuitionistic Kripke semantics, I'm retelling the story or recalling in a slightly varied form, you will see. We start from the notion of a frame, which consists of a non-empty set of states that are related by intuitionistic accessibility that models stages of computation or stages of construction that increase the information content of a state going up in the order. And we require this relation to be transitive. And that's a slight deviation from the standard setting, only weakly reflexive. Weakly reflexive is not saying that every state has to be reflexively connected with itself, but only if a state S1 has a downstream state S2 that's reflexive, connected with itself, only then I require the S1 upstream to be reflexive as well. This allows me to have I-frames, which are with non-irreflexive worlds and they will play a role in modeling fallibility, states where all formulas are valid, which is something innocuous to do with intuitionistic logic, but becomes important for modal logic. Okay, so that's a frame, and a model is then just an extension of the frame, an iframe that well, with a valuation function. You would, in a standard presentation of intuitionistic propositional logic, now require that the valuation function is hereditary, that it's a valuation that takes a propositional variable and assigns it to a set of states. You would normally require that the set of states is upper closed. If a propositional variable is true at some state, it will remain true, but we are not going to do this for didactical reasons, or let's say technical reasons. We are pushing the responsibility of being hereditary into the interpretation of the operators. That's a sort of overriding tactics in what we are doing here. So the satisfaction relation is now going to be an evaluation of formulas to be satisfied at a certain state in a model. And well, the clauses are the ones slightly modified from the normal presentation of crypto semantics for IPL. Top is always true. Bottom, now this is now the indication of a state being fallible. So bottom holds if the state is fallible, and fallible, the set of fallible states is the set of states which are irreflexive. So because we are irreflexive now, as I said, we now have the option of modeling bottom. Propositional constant is satisfied not just if it's valid at this state given the valuation, but as I said, we force hereditariness by quantifying universally over all successor states upstream from the current state S. Conjunction, disjunction are the usual. The usual clauses. Conjunction is true in a state if both are satisfied, and the disjunction is true if one of them. And now for intuitionistic implication, which is the constructive reading of a proof transformation, we now have a strengthening over the same kind of strengthening over classical logic, which is forcing hereditariness of the implication. We say A implies B in a state. No, if upstream for every state S prime intuitionistically reachable from the S, if the antecedent holds, the succedent also holds. And as a consequence, a special case of it, which becomes important for the story that I tell, we can look at negation. A negation is satisfied in a state if for all upstream states, henceforth, basically from there on, all the constructions, if the state is not, if it's not fallible anyway, then the formula must be false. So all hereditary. So a formula is true if it's true for from now on, and it's false. Negative is not. Negation is true if it's false from now on. And the quantifications that I've indicated in red force truth to be hereditary along the intuitionistic accessibility. If a formula is true in a state, then in all intuitionistically reachable stages of construction, it preserves, truth is preserved. This hereditariness of truth is what prevents intuitionistic logic from being classical, because a formula that is not valid or satisfied in all successive states does not necessarily have to be false in all successive states. It can be contingent, some successor states true, in some other successor states false. So it's very easy here to create a counter model, the well-known two-state model, where the excluded middle generically in a propositional variable is false. I will present interpretations of formulas on those frames a little later, so I'm skipping this. Well, this is well known anyways. We're going to look at the interpretation of modalities downstream a bit. So that's where it's more interesting, or where it's more sort of novel. We define validity on frames. That is all I need. A formula is valid on a frame if it's satisfied in every model that's built on that frame in every state. And we have soundness and completeness for this intuitionistic interpretation. The intuitionistic propositional axioms and the Hilbert calculus will generate the formula generically in the propositional variables if and only if this formula is a frame property for all those iframes with these tactical modifications that I've made to the standard interpretation. Notice, if you're not familiar with intuitionistic logic, what's interesting is two things are interesting. One is if the relation is reflexive, then there are no fallible states. Sorry, the other way is better. If you take a state S that is irreflexive, you can check that every formula is automatically valid in that state, not just the bottom, but also implication, no? And the propositional variables are immediately validated. So being fallible is the same as being irreflexive, is the same as validating all formulas. And the other thing that is interesting here is that if the intuitionistic relation is the identity relation, these red quantifications collapse, everything collapses to classical interpretation of the operators. Mm-hmm. Okay, that's the other thing to notice. Good, okay, that's enough. So this is the basics. And now we go into modalities. Constructive modalities here, and we look a little at the, well, what has happened about modalities. Well, modalities themselves have been investigated in logic philosophy for a long time, thousands of years. But the intuitionistic versions of modalities has started relatively late. Well, as far as I'm aware, with the 1940s. I mean, with the constructive logic, of course. Eventually, then modalities would have been considered in this setting. Most of it is on the box modalities for a start, not so much on the combination of box and diamond, and very little on negative modalities. The literature that I mean, here's a list of, it's just a selection, an incomplete list of papers on modalities. What I'm going to do, also the negative modalities are prominently propagated and developed or investigated in Došen and Bořič, which explains the title of the talk. And the specific interpretation that we apply to the box and diamond modalities come from work by Vizikera from the 1990s, and that I have continued to develop with Depayeva, Scheel, and others later. So the work we are doing now in the following is kind of extending the, let's say, combining the green work, yeah, a special interpretation of the positive modalities with the red work by Bořič and Došen. No? That's basically what we're doing now. And the relationship with the other work is something that comes later, which would be...
sorry to interrupt.
Yes.
So what was new about the green ones that was
I'll come to that in a moment.
Work compared to Došen and Bořič?
Yes, you will see in a moment. I'll come to that. It's okay. Yes, it's exactly the question that I'm now. Well, 2 slides, maybe 3 slides down. So let's look into Došen, who has given a very systematic investigation here as a good reference. The axiomatization, so Došen has investigated these modalities independently from each other and well, characterized them in terms of axiomatics and semantics. Looking at the language that contains just the box, Došen call this the theory HK box, is an extension of intuitionistic propositional logic with distribution axioms that explain that the box necessity essentially distributes with conjunction, which is natural because if let me read it. Necessarily A, necessarily B implies necessarily A and B is a distribution that allows you to pull out a box in front of a conjunction. And the nullary distribution of a box also into a conjunction is this second axiom. The nullary conjunction is top. And if you take the box of top, you get the nullary conjunction, the nullary case of that right-hand side, which explains the second axiom as a zero array degenerate case of that. This is natural because a box implicitly semantic is a universal quantifier over possible worlds, and universal quantifiers distribute over conjunctions. Now, these axioms need to be extended with a rule that is called the regularity rule, R box, which puts which allows you to put a box around the antecedent and the succedent of an implication that has been proven as provable generically in Hilbert sense.
Excuse me, why did you formulate this second axiom in this way? Truth implies box truth. Why not say just box truth, where we are supposing intuitionistic propositional logic?
True.
Right? So,
yeah. So it is. I do this because it's simple. You're right. This is the same as box top. I do this because so that for didactic reasons that you can see this is the nullary distribute, the nullary case of this.
Okay. So it's kind of analogy to axiom number one. Okay.
That's right. So the top is the empty conjunction, and box top is the box of the empty conjunction.
Okay. Yes.
Now this regularity rule has two effects. It gives you the implications in the other direction, which really makes these axioms as powerful as a distribution both ways. So box distributes across nullary and arbitrary finitary conjunctions. And also the regularity rule makes the logic extensional. If you can prove two formulas are equivalent, you can replace these formulas in modal context without changing the meaning or the truth value of the composite formula. Very, very important. It's I would call this an extensionality rule, in fact, but well, it's also called regularity in Došen's work anyway. Now, looking at the language with a diamond, you would expect the diamond is an existential quantifier over possible worlds. This diamond to distribute over this junction, and that's the axiom that Došen puts forward. In fact, all modal logics that I know will give you all normal modal logic, I should say. And now we come to in a moment. I come to answer your question. If all normal modal logics will make the diamond distribute over this junction in the binary case, and that's the nullary case. Let's check. The nullary empty disjunction is bottom. So here we have the diamond of the empty disjunction implying an empty disjunction of diamonds, which bottom. Not diamond bottom is a nullary case of this distribution. Again, we need to lift modus ponens or implication into the diamond context with the regularity. And now we come to the sort of the tricky bit is the tricky modalities are the negative ones. And I think that's a novelty that Došen has really introduced at the time in '84, given that these two modalities have been discussed before, long before already, but these ones not. Unnecessity in Došen's understanding is a modality that distributes over conjunction in the binary and in the nullary case. If you read it, if it's unnecessary that you bring flowers and a wine to the party, then it's unnecessary you bring flowers or unnecessary you bring wine. Or if you say, if you concede the absence of flowers and wine, then you're conceding the absence of flowers or you concede the absence of wine. Makes sense somehow?
Here there is, if I may, the issue of constructive reading of disjunction.
Yep, exactly. Exactly. This makes this a little dodgy. Yeah. And you will see the semantics that in the end is not a problem, because the theorem says all of these modalities, I mean, all of these axioms are compatible with constructivity. No problem, no problem. So they are constructive, and Došen has proven it. But they are very sensitive to how you extend them. I may come to that.
So this principle is really strong because it really states something substantial. So
indeed. So this is something that sticks out, if you know. For instance, if you put negation, if you cannot interpret a necessity as negation anymore, because if you replace this by negation, you get not A and B, implying not A or not B, and that's of course not constructively possible. No. So this, if it is constructive, and it is constructive, the a necessity is an interesting thing. Now, I can understand that if you say you concede the absence of something, if a necessity is conceding the absence, that a proof of the fact that a proof that concedes the absence of something contains information from which you can decide, that gives you that allows you to concede. No, the absence is conceding one of the two. Because this is a possibility. It's not, you can't exclude that, but it's not a negation anymore. Not an intuitionistic negation.
So there is something like a proof. So if you use this proof theoretic kind of interpretation of intuitionistic logic, so there is a proof that there is that A and B are not there, so to say. So there is a proof that A and B are not.
Yes, if you have a proof that allows you to avoid both, this proof gives you a decision and some sort of recipe, and tells you a kind of a tag that tells you which of the two you can avoid, and a proof that how you can avoid it. I think that's more or less what
this principle says.
It makes sense, but I have to say we are developing this modality. You see, there's a problem. You'll see in a moment there is a problem with this, but comes from a different angle. Okay, comes from we'll see. Now the final modality is the impossibility, and Došen has axioms which complete the picture in some sense. Distribution, of course, distribution of impossibility over, well, disjunction now, rather than distribution of a conjunction, which is what a necessity does. That's innocuous. If distribution, if A is impossible and B is impossible, then it's impossible you have the disjunction. And that's in fact consistent if you compatible with reading impossible as negation, intuitionistic negation. No, that's perfectly okay. And the nullary distribution, again, in this awkward, roundabout, inflated way, top implies impossible bottom is of course equivalent to impossible bottom. Now the regularity rules for these negative modalities goes the other way around. If A implies B, then if B is unnecessary, the succeeding is unnecessary, the input antecedent is unnecessary, or if the output is impossible, the input must be impossible. That's also quite natural, well, logically forced on us. Anyway, now Došen shows in this work from '84, and Došen and Božič together that first of all, each and every one of these systems, I call this HK, with the modality you choose it, any one, by itself is constructive. But he has not, for some reason, systematically developed the combination of these axioms, of these modalities and axioms, for a reason that will transpire in a moment. If we ask for combination of the modalities in the literature, we find combinations of box and diamond only, but not negative modalities with positive. For instance, in 1980, Fischer-Servi has defined a system Fs that's known as Fs, later recovered or rediscovered by Plotkin and Sterling, and Simpson, Alex Simpson, in his PhD, who call this system IK, intuitionistic K, is a combination of the axioms, distribution axioms for box and diamond, plus two further axioms, interaction axioms between box and diamond, FS5 and FS6, they're called in the terminology of Fischer-Servi. Let's not bother about these, what they mean. This is, they're generating a constructive logic, combining the positive ones. If you look at Bossig and Došen, then they have, for reasons it's not so clear, a little later defined a combination which is HK box and HK diamond together with two funny axioms, interaction axioms, box diamond, and box 1 and box diamond 2. Box diamond 1 says introduce a disjunction outright, generically instantiatable in the A. For every formula, either it's possible or it's necessarily not. This cannot be constructive. It is not constructive. In fact, with box diamond 2, which says that possible A and necessarily not A, they are incompatible. They basically tell you that for every formula, either diamond is true. No, this is one of or the box not is true of the formula. It's basically a classical, makes the modalities become classical in some way, and it's not constructive. Where Fischer-Servi, Plotkin-Sterling, this system is still constructive. Now that's positive modalities, but we are interested in the negative ones, and here where trouble is looming. The combination of positive and negative modalities creates problems, subtle problems that are there that need to be solved, and that's what we do here in this paper. We have first make a definition.
Excuse me. So speaking about, so this Fischer-Servi logic is sort of better known than Došen's one.
Yeah.
To me at least. But so what was the motivation of Došen to take these additional two principles? So what did he want?
I don't know. I mean, I could not. I haven't read all of the works that is very available, but in the standard publications, I think it's just they are curious about how you combine from the frame theoretic, from the model theoretic point of view, and in the way I will develop it in a moment. They have found that it's possible to combine the two using their semantics, and that's what comes out.
So they had some kind of interpretation, semantics for the logic for which these two principles were sort of
basically, that developed these axioms from the semantics. Yes, and you will see. I give you the semantics in a moment because there's a problem with it, and this problem is probably the reason why Bossig and Došen have not continued this work, or at least this is a. Let's say this is a possible, speculation, and it basically stopped this. And something needs to be done to the semantics of Bossig and Došen to make it work, and that's sort of what we are now looking at. So here comes the technical story now. We start with a definition. We define a theory in the full language. We're interested in all of the modalities. To be a Došen theory if it contains all of these distribution axioms for all of the modalities and are closed under the regularities rules. So we basically we form we look at the fusion of all of them, and of course the smallest Došen theory is the proof theoretic fusion. We define let's say call it HK all, the theory that is generated by taking all the distribution axioms together with the regularity rules, of course. And well, that's a Došen theory, and it's constructive. That's not something that I found in the papers by Došen, but maybe they should have been aware of it. So just proof theoretically fusing all the modalities is okay, constructively okay. The trouble is, of course, it's not satisfactory because we have no interaction whatsoever between the modalities. No, for instance, there's no way in which this HK all fusion will allow you to derive that possible A and impossible A are contradictory, which is something you want. None of these distributions will make possible and impossible interact in any way. So right, that's not the real sort of combination that makes the modalities talk to each other. Is a frame theoretic fusion that starts from the semantics. And here is the semantics that Došen has put forward. It's extension of intuitionistic Gubke style, of Gubke semantics that I've presented before. I call this, to have a playground, a very rather generic setting, call these C frames, constructive frames. They extend intuitionistic frames with a binary modal accessibility relation that we use to interpret the modalities as quantifications. Birelational. By the way, yeah, so Tirov, I mean, in others, it's folklore that this theory, such theories that are just proof theoretic combinations of axioms, would correspond to a frame theoretic semantics in which all of these modalities are interpreted on independent modal accessibility relations. Right? But that's not what we do because we want interaction. We have a single relation R that we use to interpret all of them. Yeah? And we define models then based on this, in a standard way. Models extend the frame by evaluation. And now here comes the branching point between what we do and what Došen has done. We have in Došen's world, in the sort of old 84 papers, he defines a class of HK, let's say times frame, HK modality model frame, that has to satisfy frame properties in order to make the interpretation on these frames hereditary, to force the logic to be constructive, intuitionistic. The frame properties are the intuitionistic accessibility must be reflexive, which eliminates fallibility, basically, and more importantly, we have to impose frame conditions, which are going to be displayed on the next slide. And a model is a HK model. A Došen HK model would then be a C model in which the frame satisfies these conditions, these extra conditions. All right, now you will see in a moment why, or explain now why the frame conditions are necessary. It's because the interpretation of modalities that has been applied by Došen, in fact, by many modal logicians in history, I mean, up to Visekera, and now here we are. Visekera comes in 1990 with a different version, and Plotkin and Sterling also have done something like that. But let's not jump ahead. We look at Došen's interpretation, which is a classical interpretation of the modalities as quantifications. So necessarily A at a state is saying for all modally reachable worlds that the formula is valid, satisfied. Impossible A says for all states you can reach through a modal step, the formula is false. So for all true, for all false, makes the universal affirmative and the universal negative statement. And the diamond is the existential, the exister successor where it's true, and unnecessary if there exists a successor where A is false. That's the classical reading of modalities as in classical Aristotle or classical modal logic. But the logic becomes intuitionistic because we're working on frames that are not free, but frames that are kind of condensed or constrained by frame properties. And these frame properties, I call them F box diamond, box impossible, F diamond, and F unnecessary, are inclusions between sequential pre and post compositions of the modal accessibility with the intuitionistic accessibility in all the four ways in which you can flip intuitionistic accessibility in front or after the modal step. Very formally. In any case, these are necessary and sufficient to make these classical clauses become hereditary, so that at any point in the model, when a formula is valid and you move forward to a intuitionistically more informative state, the formula is also valid. Again, that's the kind of, that's the story. And with this, in this sort of frame class, individually for every modal operator, Došen proves that the distribution axioms for that modal operator generate a formula if and only if this formula is valid on every on all the frames that satisfy the corresponding frame property. But individually for every sublanguage. Now what happens if you combine that? And now you see this thing is crashing. Let's define the set of dozen frames to be the C frames that satisfy all of these frame properties simultaneously. And then look at the theory, the logic, I call this DF, calligraphic DF for the frames, and a normal DF for the theory, which is the set of all formulas that are valid on all the dozen frames. So we superimpose all these frame conditions on the single relation, modal relation, and this generates the theory, DF. Well, no problem, of course. Sure enough, DF is a dozen theory because we build in the properties. So it satisfies all the axioms. It's closed under regularity rules. And sure enough, now we have interactions. We have the interaction in particular that possible A and impossible A are contradictory, necessary A and unnecessary are contradictory, and then some other things. And well, it looks good, but the trouble is now we have too much modal interaction. The modalities are talking too much to each other. The frame does not leave enough room for the modalities to develop independently, and it's really drastic. If you look at the details, not really difficult, but striking to make the observation. No modality in this frame theoretic fusion has any constructive content anymore. So you can prove that never take any of the modalities, any of the four modalities, read it as a plus modality, and consider the corresponding contradictory partner, the opposite partner with a minus in the circle. So if the plus is the box, the minus is the box with the minus, and if you take the impossibility for the plus, the corresponding contradictory partner would be the possibility, all across the board, complete symmetry. Then you find that in the dozen frames, every modal operator is equivalent to the negation of its partner. And by extensionality, this means every modal operator is equivalent to its own double negation, which crashes, in intuitionistic logic, crashes the modal operator to be information free. A classical makes it behave classically. And in fact, you even get for every modal operator that you can prove the disjunction. Necessarily A or not necessarily A, possibly A or not possibly A, etc., etc. And that is, of course, not constructive. And that's the reason I suspect why this story has stopped, at least in Došen and Božič. Now what we do is we deviate in the following way. And by the way, this observation that we have that this combination of modalities with the frame properties is something that implicitly has been discovered by Dobišević in some work that he has published. I don't know when it was, 2013 or maybe earlier. No, but not for the dozen theory, but for the logic n star, which is a logic of negation. And you can derive this logic n star as a theory of this fourfold modality, where you collapse the modalities to behave like negations. So here comes the main contribution, let's say contribution, the insight that we have here. Namely, what you can do is, instead of having the frames be structurally redundant with the frame properties, you leave the frames as they are, free frame structures, but you put the responsibility on being hereditary, intuitionistic, on the interpretation of the operators. And the way to do this, of course, is to make all of the classical truth clauses for the modalities be forced to be true along all intuitionistically reachable successor states from your observation point S. That of course forces the heredity without needing the frame to have any properties whatsoever. This double quantified this is a double quantified interpretation modalities for all exists, for all exists, is the special nature of our interpretation that will give us a constructive modalities. The other thing that makes this special is that our ordering need not be reflexive, giving us fallible worlds, but that's a little beside the point. It is not so central to solving the problem that Došen basically poses. The point is now look at I'm changing the interpretation symbol of Došen's classical interpretation, which, if you noticed, used the forcing symbol back to the validity symbol, the model symbol, to distinguish the two interpretations: the double quantified interpretation, which is not the one we are now going to use, and that's the CKD semantics. So a bit of history. The double quantification has been, I think, I'm not sure 100% sure, but I think has been discussed by Plotkin and Sterling in their work in 1986, which is not so dramatic, because intuitionistic interpretation of universal quantification, if you take the standard predicate logic and you take the Kripke semantics for predicate logic, you can see that quantifiers, the universal quantifiers, come with an intuitionistic quantification of an intuitionistic frame. This quantification, but the use of this quantification, double quantification, in front of an existential, that's truly new and surprising in the work of Visikera from 1990, which I have used independently in work on propositional lax logic in '94. I wasn't aware of Visikera's work that I was pointed to by Valeria de Paiva a little later. So Visikera is basically this discoverer in some way, or the first to dare force heredity through extra universal quantification. And nowadays, this quantification, double quantification, is what distinguishes constructive model logic from, and this would be a non-normal model logics, from intuitionistic model logics as they have been introduced traditionally. The special contribution we are making in this paper is that we extend this Visikera, Mendler constructive interpretation to negative modalities.
So constructive now means with this more relaxed semantics without interdependence between.
Yeah, that's right. Yes.
So here, of course, it seems that general problem that arose in this Došen approach was that when you read semantics, when you read your logic from Kripke models, you need to treat your Kripke models constructively as well. So
yeah.
So if you have classical Kripke models, even though they are of intuitionistic logic, you will get something extra information which is not supposed to be there for these modalities, for example. So by the way, this first constructive proof of Kripke completeness result for intuitionistic logic, I think it was in, so it's there where they discovered that these fallible worlds are actually needed, right? So that was even before that, right?
Johnson. Yes, that's true. So the fallibility, I'm not so familiar with, I'm not concerned with intuitionistic meta theory. You should say that, yes.
But I think it's somehow intrinsically related, this.
But it could
this
be,
question.
Yes.
So so this definition that you are showing us, it makes more sense constructively than. So it's
yes,
probably maybe even completeness proof after you. I suppose you will have one, but
yeah, maybe. I have one, but it's classic. It's a classic meta theory. Yeah, okay, it's good point. Yes, that'll be exciting to see. All right, let's apply this logic, and we come back to the initial. Now, I want to come back to the beginning of the talk, both on the model theory and the proof theoretic side. On the model theoretic side, we had this situation, Romeo and Julia, in a discussion about dirty dishes and squeezing through a narrow door, where they end up in a discussion that is a kind of a metastable state of affairs, where we have 2 points, 2 states that are each of which is connected. Well, intuitionistically, they're intuitionistically simulating each other, modeling a kind of oscillation and cyclic structures, right? And at each of the points, there is a way of realizing the step, the action, to x prime or y prime, where we switch between the 2 options that we have in each of the cases, me and you. So we can, if we make the x prime model u and not me, and symmetrically, the opposite would be to have me true, wash the dishes or squeeze through the door, and not you on the other end of this oscillation. This double quantified interpretation that we now are proposing here is giving us, is rendering the situation. I mean, gives us the logic theory we want. You can verify that in every one of those states, necessarily you or me, because wherever you go intuitionistically, no matter what the sort of, let's say, uncontrollable oscillation is doing, whenever you take a step, no matter, there will be you or there will be me, for sure. Also, at the same time, impossibly the conjunction. No matter what happens intuitionistically, where you actually perform the action, you will not have both. It's also good. That's what we want. But individually, none of the propositions me or you is not. All of them are not possible, not necessary, not unnecessary. All across. They are not necessarily me holds because, let's see, not necessarily me means because no matter where I go intuitionistically, it's always false. It will always be false. Diamond will always be false, and possible is false if there exists an intuitionistically reachable state where you can perform the action so that it's false, and that's true. No matter where you are, you can find an intuitionistic reachable. You can continue and make a step, and then u is false, or you can continue, find a step, make a step, and me is false. So not possible me, not possible you, and you can verify all of the other cases. They're not only false at each of these states, in fact, their intuitionistic negations are true. So they're in a stronger sense false than just not being true. Anyway, that's the theory we wanted to see. And it shows that our interpretation is now, in a sense, more constructive because it models this metastability, metastable states, which classical logic cannot model. Oh, at this point, I'm running out of time, but there's something interesting about it. The theories, if you look at the theories, the formulas that are true at these blue points, because they are in an intuitionistic cycle, exactly the same formulas are true in X as in Y because of heredity. So we have 2 states which are models, elementarily indistinguishable, but you cannot collapse them without change the theory. So that's interesting, and this is where the constructive interpretation deviates dramatically from the normal interpretation of intuitionistic model logics. And in my intuition, but I can't really make it very concrete, my intuition is that the fallible worlds are a situation where you don't have a choice. Here you have a non-determinism with a choice of 2, and a fallible world is a deadlock, a real deadlock, no possible choice, no matter as a kind of empty set of choices, which is the real deadlock. Here it's just a non-determinism. The problem is it's metastable, so you don't know when the action is actually happening. You need some sort of creative, maybe some creative step that pushes you in either day. Anyway, I'm sorry, I'm becoming mumble grumbling here on things which are not in the formulas. Let's finish off.
If you identify them, you have one point from which by R you can reach two different points, right? So that's the property which gives you sort of non-determinism, which was absent in the original model, so to say. So
you have a non-determinism, but it's not.
So from X you can go only one way by R, and from Y you can go only one way. But you identify them, you lose this property. So.
Yeah, not possibly me depends on the fact that it's only one, not two you can reach. You can always find a point where whatever you do is not going to be me, and that's okay for washing the dishes, no? But if you identify the two, you have two. You can reach you and you can reach me. So it's not the case that both steps will give you not me. Yeah, very good. Yeah, that's right. So this is sort of this makes this example important for the whole sort of for the game. We play constructive versus intuitionistic. Well, how much time are left? Is I'm now running out. No, we have 1 hour. So
no, you are not running out of time, because normally our talks can be up to 1 hour and a half. So it's wonderful. Perfectly all right to use your time. So
great. Okay, good. So now what we are left is we've seen the new interpretation, double quantified interpretation, call it a constructive interpretation with a free frame class. And now we are missing the proof theory, putting the theory that we've defined semantically into operational terms. And we have two systems. The Hilbert system, Hilbert axioms consist of is IPL, of course. We have what are called the K axioms. The K axioms are internalizations of the regularity rules. For instance, box K, diamond K, each of these K axioms internalizes the regularity rule for the respective modality. For instance, now you have, if you have necessarily A implies B, then necessarily A implies necessarily B, internalizes the fact, this rule that says if you have A implies B above the line globally, then you get box A implies box B. Now, the premise of this rule is internalized into an antecedent that is boxed, to represent the fact that the implication is a global implication on the top of the rule, in the original dozen theory. And you can recognize, if you apply that sort of idea, you can recognize the other three axioms as the regularities for the other modalities. Now, this system will give us basically just the HK all, the fusion, the simple fusion without any interactions. Extensional logic. The interactions come from two kinds of interactions fall into two classes: interactions between two modalities and interaction between three modalities. What we call the two axioms discuss the interaction between specifically impossibility as a universal but negative statement and every one of the other modalities. Just look at one. It is a natural thing to state that if a disjunction is necessary, if A or B is necessary, but at the same time A is impossible, then the other disjunct must be necessary. Now, how can a disjunction be necessary with an impossible disjunct without the other disjunct being the part that is necessary? And the other three are considering the impossibility interacting with a diamond, a disjunction under a diamond, or impossible A, then impossible B implies impossible A or B. That's the axiom H, the distribution axiom, really, of Došen directly. Yeah, it's not so important. We can read them, and interesting would be to see what proof theoretic constructive content of these axioms is. We don't know. We have model theoretic we have a model theoretic explanation, but not a proof theoretic one yet. These n axioms capture the interaction between three different modalities. Calling them n axioms, I have to admit, is not very wasn't very enlightened. Don't ask me why I call them n axioms. Again, my mouse is frozen. Here. Here we have an interaction between impossible, possible, and unnecessary. If a conjunction is impossible, and one of the conjunctions, let's say, but one of the conjunctions is possible, then the impossibility must come from the fact that the other conjunct is unnecessary. I think that's should be clear. And then N6 is another ternary sort of interaction with a disjunction. The boxes, two boxes interacting, a positive and negative box interacting with each other, and here we have a positive and negative diamond interacting. Now, all of this closed under modus ponens and the necessitation rule. Oh, that's a mistake here. If A is provable, then box A is provable, of course, is what necessitation wants to do. Okay, well, that's the Hilbert system. I have to admit also, this has been generated. I now have a story to systematically derive these axioms from a kind of fibration idea through a fibration construction that explains them, makes them compelling, possibly also constructively compelling, but I haven't written it up in the paper. We basically generate these from the to have a complete Hilbert system from an attempt to prove the completeness via canonical countermodels. And these canonical countermodels are constructed not from theories that are closed under Hilbert axioms, but using a Gensen tableau, a Gensen-Dragalin tableau system, which is interesting, I think, in itself, and brings us back to the other aspect of this work, the Došen Square, the square of modality, the modal square of oppositions, and explains why we call this Došen Square. Really, the sequence calculus is a calculus of Došen squares in the following way. Our sequence, we call them GCDK sequence, are regular sequence with sets of formulas being modeling certain dimensions of truth, positive on the left side of the turnstile and negative statements on the right side of the turnstile, 6 of them. And on top, for 4 of these four of these scopes, we also have a sign. We're adding signs for the formulas. The formulas could be positive and negative. You probably explain why the purpose of this, immediately. So it's not too complicated, but it's non-trivial still, and there's some structure to this, which comes out if you look at these sequence as squares with 4 corners that represent the squares of the Aristotelian square of oppositions, modal square of oppositions. There is a corner northwest that deals with the box statements about implicitly box statements in positive and negative form. Southwest, you have the corner that represents, externalizes in some way diamond statements in positive and negative form, and you have a southeast, the unnecessities, and northeast, the northeast corner, the impossibilities. And and in the middle, the center chord, the standard sequence statements, things which are positive at the state and things which are negative or to be concluded are negative in the refutation interpretation, negatively true at the state. And and in this notation, linear notation of the sequence, a set like theta, the position here on the left of the turnstile really splits into positive and negative formulas, which sit the positive ones sitting north west, and the negative ones sit on the positive side, and the negative formulas in that scope come to sit on southeast corner in negative position. So each of these sets has two splits into formulas that come to sit on two opposite sides. More or less, that's the strategy. And the logic is now developing from this structure rather naturally. In the, for instance, looking at the introduction rules. What's an introduction rules for the operators? What's an introduction rule? Here we are looking at introduction rule of a necessity. The unnecessity statements.
Excuse me. So I'm somewhat confused about this picture that you have.
Yeah.
So what does it mean in terms of is there such a thing as translating your sequent into a formula of your logic?
Yes.
So how does it work if you translate it? Is it related to this picture or not?
Yes, I show you. We can translate this, yeah. So here you can see the slide. Yeah. So you have a sequent. And the sequence contains each of these scopes, the positive and negative ones. So what we are doing is we translate, the sequence translates into an implication as you would expect. No, the center chord is the main, it's an implication. And all of the corners, they get internalized in modalities on the left and on the right, conjunctively on the left, disjunctively on the right. So here, as you see here, the gamma stuff in the center become conjunctions of gamma formulas on the left. The pi stuff, the pi in the center chord becomes disjunction as usual on the right. Okay.
So pi and gamma occur once, but delta, sigma, theta,
delta
and psi
occurs twice. Yeah. The positive formulas in the delta occur with the positive formulas in the delta occur as diamonds, and they're all conjoined on the positive side. So the positive formulas in delta are diamonds on the positive side. Here, the negative formulas in the diamond in the delta are impossibilities. And they go on the disjunctively into the succeedent. And the same. There is a little incoherence here, or a little asymmetry that I have to point out as interesting for me, or important for me to point out, specifically here, these two. If you look at the translations, you see that on the negative side, we have a whole sequence of disjunctions, but it's interesting that when we look at the negative signs in the sigma and the delta, then the order of the modal operator and disjunction changes. The negative signs in sigma are first disjunctively combined, and then you make the disjunction possible. Whereas if you look at the negative formulas in the delta and in the psi, you take each one individually and you modalize each one individually, and then you form the disjunction. So, and here is where it's important that our semantic, the double negation, double quantification, avoids or prevents the diamond from distributing over disjunctions for free, and it also prevents the unnecessity from distributing over the conjunction for free. Remember what we said at the very beginning, this axiom of distribution of necessity or disjunction is a bit dubious. And this translation of this semantics avoids that dubious axiom, which is it's constructive, but maybe not in all cases, not in all of the theories that you may want to generate.
Okay.
Yeah, well, so thank you for the question. It's a pretty detailed. That gives me a chance to. Is that okay?
Yes. Yes. Now it's clear.
Yeah. Yeah, that's a sort of the first. Yeah, so maybe we give you one rule in the sequent calculus, and we almost. Well, I need to. Well, it's actually the three classes of rules. We have these introduction rules. So the idea would be that an A in the southeast corner is a necessity statement, and the introduction rule in sequent calculus is to internalize. I mean, you have these formulas distributed in the sequent, and an introduction rule is to take the formulas and introduce a modal operator from a formula that doesn't have the operator. So if you have an A in a necessity statement, the rule allows you to bring this necessity into the center chord with a modal operator in front, and that's very similar to how sequent calculus generates a conjunction from a disjunction from a comma on the right. No, a disjunction introduction. Sorry, a left introduction of a conjunction here internalizes a comma in the context gamma, and turns the comma into a conjunction. Here we have a comma in the southeast corner, and we turn this comma. Well, it's not the comma, but it's the A added that is now internalized, rendered explicit in center chord. And you can imagine in the same way the left introduction rules allowing you to move a formula from a positive statement, a formula in a positive position, from any of those corners into the positive position of the center chord, adding the modal operator that you can see attached to those arrows, which explain what these formulas mean in these corners, relative to the center, relative to the Hilbert in some way, relative to the Hilbert formula that closes this sequence into a closed form.
So in terms of your translation, you showed us before, both premise and the conclusion of the rules are sort of the same graphically, will be in this case, because formulas in the above.
Yeah, indeed, yes. Yeah.
Okay.
That's right. So in some cases,
the translation.
Sort of. Yeah. So there's some redundancy in our system, which is not necessary. If you want to be irredundant with the presentation, if you apply Occam's razor to this calculus, then you get something that's a little simpler. But we've chosen to do this in this sort of exploded form, so that the symmetries become clearer, and it feels more compelling, the whole thing, at least systematically, more categorical. But yes, you're right, there's some redundancy here. If you look into the details, maybe interesting is the right introduction, because that's where you see the intuitionism, the constructivity, or the intuitionistic side of the intuitionism or constructivity, which, if you remember well, let me look at the rule. A right introduction for a necessity formally would be, you have a formula in southeast, in positive position, as on the right of the turnstile in southeast, and you want to introduce this with the modal operator into center chord in the negatives, on the right side. Then this is a right introduction rule, which is okay, but like in right introduction rule for implication in intuitionistic logic, you can only do this if under a constraint that forces some scopes to be empty, which means that the formula that you're introducing, or the principal formula from which you're introducing, is unique. If you know, the intuitionistic logic arises from classical multi-sequent logic, Dragalin, if you make the right-hand side single conclusion in the implication introduction. That's the only place where the intuitionistic so introduction or system deviates from the classical. Same situation here with the necessity. The necessity implicitly is a universal quantification over intuitionistic successors, and by, well, it's probably taking, I can't explain. If you go through the semantical validity conditions for this introduction, you find that because the this step, if you look at it backwards as a transformation of a refuting state for the Došen sequence of the succedent into a refuting state of the antecedent, this rule, this introduction to the right, corresponds to an intuitionistic step forward in the model construction. And in such an intuitionistic step forward, you cannot maintain the information in scopes that are not hereditarily quantified. And the only hereditarily quantified information in the Hilbert formula or in these systems is the sigma plus, the gamma, and the theta plus. These three are hereditarily strong. And since you make a step, if you read this rule backwards, intuitionistically forward, you can carry over this information into the successor state, but you have to drop all the information in all of the other scopes. If you know the countermodel construction or the refutation semantics of sequent calculi, you call them tableau calculus, then this is a consequence of the intuitionistic nature, or the fact that the information you have locally here, this is information about a local state, and not all of this information, the red positions specifically, are global information about the model intuitionistically forward through all intuitionistic steps, but just local information about immediate model steps. And this information is then brittle and goes down the drains in the treatment of the modality. In this case, it's the intuitionistic step. So that's a bit tricky, or let's sort of but it's natural from the intuitionistic semantics point of view, a little unexpected from, say, the systematics. If we remove this construction, we will get classical interpretation of modalities, I would think. Well, then we have, these are the rules to introduce on the right and on the left, the modalities, modular restrictions. What's missing is the introduction of the signs. And that is done with rules that we call the grand modal dispatch rules, or also contraposition rules, CP on the left, CP on the right. Here we introduce the signs, for instance, with the rule CPL minus, we allow ourselves to take a formula in the gamma set in the premise, and from this formula we can introduce a negative sign in the delta corner, or with CPR plus we have a formula in the pi set, and the rule allows us to take this formula into the that's the southeast positively. So this is how the signs get introduced in the forward use of the rules. The rules we've seen before are the rules that introduce the modalities in forward direction. And in this way, everything then, well, that's all, gives us a calculus which is completely analytic, building up the conclusion sequence from the subformulas of the conclusion sequence or backwards. Creating a finite search space. Do you want to see an example before we conclude?
Okay.
Just to illustrate, and that's going to be the end. There's the results coming. So in the application of the sequence, we would, well, for instance, we want to prove the incompatibility of possible A and impossible A. So it's not the case possible A and at the same time impossible. We start a sequence with the statement with empty context, but the statement in focus on the pi. And we apply the normal introduction or rule of intuitionistic logic backward. First, we create the Došen Square. Rewriting this in two-dimensional form. So parallel, kind of parallel linear notation in Došen Square. So we're looking at the Došen Square with a center chord that has one formula in focus on the right. We apply the introduction for negation, which this is the standard intuitionistic Dragalian or intuitionistic introduction rule for negations. In order to prove a negation on the right, you assume the formula on the left and you prove contradiction from it. Then to prove a contradiction from a conjunction, the introduction rule for the conjunction is to replace the conjunction, is the end introduction, replace the conjunction by comma. And now we have two modalities in the positive context. And if you remember what I said, the corners, the purpose of the corners is to externalize the modalities in the center chord. So we use the left introduction for impossible and possible to put this occurrence of A into southwest as a positive into the diamond corner southwest, and the impossibility of A, take this A into the impossibility corner northeast positive. They're both positive side, so they remain positive. And well, now we use this the sign introduction rules, the CP, the contraposition rules, which allows us to bring which corresponds to a modal step, the creation of a modal step in the counter model construction, which focuses on here we have predictions about what's modally reachable from this state. And here we are realizing this state, and the predictions A plus and this A become an A on the positive and an A on the negative side in this modally reachable position. And remember, an impossibility basically says a formula is impossible. No matter what step you do, it will be negative, it will be false. Impossible, it says a formula is possibly reachable. So we use this possibility here is creating the step, bringing the A into positive, but at the same time the A is impossible. So we have an impossible A here on the negative side, and that is now a situation in center chord that can be closed off in the axiom system directly, and we're done. Well, now we have the results in the paper are the usual standard results you would expect. The sequence calculus, now we prove completeness and soundness using consistent saturated squares to build counter models for unprovable end sequence. And we have this, as you asked, in fact, a structural translation, one-to-one, a local translation between steps in the Gensen system and the Hilbert system. But I have to say, this is not complete. It's not it has a constraint. The constraint, I don't completely understand this yet, but the constraint is that the sequence have to be polarized, which means we can only have one. The negative formulas in the theta and in the sigma, we cannot have more than one in these positions. Well, this has to do with the distribution of the diamond over disjunction and the necessity of a conjunction which doesn't hold, and with the double, of course, then ultimately from the double quantification. But for this special class of sequence, we can translate into Hilbert. And the observation is then, because of the way the calculus is constructed, there's no cut rule, no cut. So we are, and we have a subformula property. We get, we have cut admissibility from completeness and a finite search space, which generates decidability. So working backwards to the equivalence with the Hilbert system, now the Hilbert system is sound and complete. And well, constructivity can be proven by model theoretic means, but also proof theoretic means. That's not difficult. We have finite model property. Yeah, I was missing that from the sequent calculus, no, because it's analytic subformula property, finite model property. But it's important to point out that finite model property holds only because we allow our intuitionistic relation to be cyclic. The cyclic structure keeps finiteness. If the standard theory, which assumes you have trees, if you want trees, the trees will be infinite. If you unfold, bulldoze the cycle into a tree, into trees, you have you don't have finite model property anymore. Notice that the interpretation is double quantified for all exists, and this double quantified interpretation is critical for. Well, this is where the finiteness goes down. For trees goes down the drains. So finite model property, yes, but we need cycles. Oscillation cycles, no problem. And what I cannot show is that many of the modal theories that have been discussed in the literature, in particular theories on negation, can be understood as axiomatic extensions in certain fragments of this series CKD. So it's a playground, a springboard from where, very conservative in some sense, springboard from modalities, all of them, from where you can then collapse the things into existing theories in many different ways, constructive or non-constructive theories. And finally, the most, let's say, an important question that is answered is now coming back to the motivation. Initially, Došen, if you take the theory we have here, CKD, and you add all the distribution axioms of Došen, 4 of which in green are already part of CKD anyways. So we are looking at CKD with distribution of diamond and the nullary distribution of a necessity, the binary distribution of impossible, and take those in addition. That's constructive still. And it is a Došen theory because it has all the axioms we want. So that completes the, yeah, I think that solves Došen's problem. The question he has never asked, but could have asked, is it possible to combine my axioms in a single system? Yes, it is, but you have to change the interpretation of the modalities to be constructive rather than the standard intuitionistic. And that's the conclusion. Interesting future work on my side would be to look into the constructive interpretation of proofs as lambda terms and to try a syntactic cut elimination proof. Stefan and I have done this for the system here. We have done this already for the CK logic, which is the CKD in box and diamond. This is the Vésiquera, but with fallibility. Vésiquera doesn't have fallible worlds. The fallible worlds are tricky for lambda calculus. Also, the distribution of diamond over disjunction is tricky for lambda calculus, for type theory. And this work could possibly would be interesting to develop, but might be give interesting insights into computability, notions of computation for negative statements. There is a completely different way of doing semantics that's not for constructive model logic, specifically the CK, Vésiquera kind of theories, based on topological neighborhood semantics that comes from Kojima and is now recently developed more detail by Del Monte and others. This semantics might be more useful for studying correspondences between axioms and frame properties. And yeah, and then if you want to implement this theory, you want to look at efficient calculi that terminate very quickly and make the search space small. Particularly talk about, well, I don't know if that makes sense if you're not into it. For technicians, it's about avoiding duplication of formulas, getting rid of duplication as early as possible, and making the sequence become smaller and smaller, and not repeating. blocking conditions. And that's it. Thanks a lot for your patience. It's been much longer. Well, I'm glad that you gave me the time to give you all of the details and your questions, allowing me to dive into some of the details I have not expected to be able to present. Thanks. Any more questions?
I have a question, but I first ask the audience here and in Zoom. So, does anyone have?
Well, I have two very small remarks.
Please.
Well, the first one is that I think it may be reasonable to replace completeness by strong completeness throughout the presentation, because I mean, clearly the canonical model construction is applied, so you have strong completeness and semantics will be compact as a consequence, right? I mean, so it makes sense to make it a little bit stronger.
All right, yes.
And the second remark is that I mean, as far as applications to natural language are concerned, I think it makes sense to go to develop the same thing in a quantified setting, of course. I mean, because you want to understand how these negative modalities interact with quantifiers, right? And then everything will become much more complicated, especially because you have these kind of De Morgan laws in HK impossibility and HK what is that? Unnecessity, right? You have these kind of De Morgan laws, and you have to generalize them, making them kind of generalize De Morgan laws using quantifiers. Otherwise, I don't think that the canonical model construction will go through, right? So there will be, and it will be interesting to understand what these are supposed to mean from the viewpoint of natural language. It's just two remarks again. Thank you very much for your talk.
Good, yes, right, true. Yes, the quantified setting, even for lax logic, which was something I was concerned with a while ago, turned out so complicated that.
But I mean, this logic HK.
It's not so
impossibility. It is already very close to Došen's N. Yeah. And we know what to do with that logic in a quantified setting, right? I mean, it's not clear what that will be if you will try to combine these modalities, but at least to treat each of these separately shouldn't be a big problem. I mean, given that we know what Qn is and what to do with it.
Yes. The problem with the nullary axiom distribution of impossibly over bottom, which creates, which destroys. That's an interesting observation that is sort of aside from this. In the propositional case, this axiom destroys the constructivity, and probably in the quantified case the same. You have to, and because you have to, the nullary distribution says impossible bottom. You cannot assume impossible bottom and be constructive at the same time as a conclusion I have, if you want the impossibility to De Morgan distribute. If you want distribution De Morgan, then you have to, if you separate between impossible and necessity, everything is fine. But if you collapse unnecessity and impossibility, like in N you do in a single modality negation, then you have an interference between one of the binary distribution from one and the nullary distribution from the other. And that's interesting. Which means there's no as you pointed out to me a while ago, because of that, constructive negation impossibility cannot have one necessity. There is no, you cannot have any formula. No unnecessity is provable. You cannot have any unnecessity provable in this system and still be constructive.
Yeah.
Seems that's okay. Yeah. And same in the quantified setting, probably. Yeah. So I interpret this as constructive logic being an open logic, open system, and a necessity of bottom or impossibility of bottom is an assumption, is a closure assumption. in some way a reference to an oracle that gives you that allows you to interpret absurdity, which is not constructively possible some way. Now, anyway, that's a detail. It's a sort of side discussion about constructivity. I was wondering if in the quantified setting you have looked at this in any detail.
Well, no, I haven't. But one of the things that I think may be reasonable to look at is that you mentioned disjunction property, and well, and of course in the quantified setting you also have the existential quantified property, that if you prove that there exists an X such that phi, that you can extract a term that satisfies this formula. But you can try to generalize that a little bit. Maybe you want to have the disjunction property not for the logic itself, but for theories of a certain kind, right? You want to prove Harp's theorem. I mean, kind of Harp's theorem in this setting, and I think this will be reasonable.
Yes.
But in general, quantified modal logic is a much more complicated story semantically, both semantically and syntactically, than just propositional one or propositional modal logic or just predicate logic alone. So you practically never get reasonable completeness, so only in exceptional cases. And well,
I mean, here you have
you need to generalize
right,
your semantics rather significantly in order to deal with.
I mean, here you already have some results, right? So I developed a quantified version of Doshen's logic N, which has the disjunction property and the existential property and so on. I'm not aware of any nice sequent calculus for this logic. I only have a Hilbert style system, but still you can generalize Doshen's canonical model construction and combine it in a suitable
Doshen's logic. So you mean Doshen's logic that was on presented at the beginning of this talk, right? With these axioms which are not completely, which are sort of trivial, making the logical connectives classical.
No. I mean Doshen's logic, which treats negation as an impossibility operator. It is pretty close to HK impossibility.
Okay, with one modality, which is
so just have one negative modality.
Okay,
right?
okay.
Then everything is nice. His way of combining modalities doesn't seem to be very reasonable.
Okay. I actually had another question, slightly different direction. So people working in areas such as intuitionistic epistemic logic, they often include the principle that A implies box A as a basic principle one has to accept, because for the reason that constructive implication means that, okay, if one has a witness for A, one has that witness already serves as a witness for the fact that A is known somehow. Therefore, A implies box A constructively. And similar principle is also, as far as I know, included in some versions of Lex logic as well. So can it be included on top of your system, so that you have sort of natural version of this together with other modalities that you have around?
Yes, I would think. I don't see a problem with A implies box A. In fact, yes, as you point out, in Lex logic, this is part of it's constructive, and it's part of it, and there's constructive interpretation of proofs in Lex logic. It's a special logic where box. It's a kind of it's constructive S4. It's like you take CS4. I think you can generate. Here I've brought up some slides here for how you generate certain theories. Adding axioms. I think you can add axioms for to get constructive S4, and then if you can add box implies A implies box A to collapse the box, and then you get Lex logic. That's how Lex logic occurs. You take constructive S4 and you make the box disappear, what remains is a diamond, and the diamond with the collapsed box is so strong that it is extensional modal operator that satisfies the axioms of strong monads modality modal operator. Yeah.
And if you just impose the condition that the modality ordering is so it corresponds to something like if that the inclusion order is implies the R relation or something like that. R relation,
yes, yeah,
one way or another. So if you just have such a restriction
in the paper, I think if you make the R be identical to the intuitionistic relation, probably that's already. I think that's it. I have a memory that's probably it. Yes, you make the both relations coincide, then the diamond is a for all exists, and that's the modality of Lax logic. Now the diamond becomes a for all exists. This is and then because the R is the same as intuitionistic, reflexive, transitive, and identical, the other operators disappear. The box is basically A is basically box A. Yeah, that's it. So identify both relations and then.
But the Lax modality distributes over conjunction rather than disjunction, right?
Yeah.
Unlike diamond.
That's right. Yes. So here in CKD, the diamond does not distribute over disjunction. You have to add it specifically to generate something that. If you want Fisher-Servi, you have to add it. The distribution of diamond over box, and then you're out of. Well, then you have a special form of. If you want to collapse the diamond in the box. Lax logic with the distribution of diamond the diamond over disjunction would correspond to the special theory, Curry theory of, I think, where the modality Lax logic is basically the Lax modality is basically a disjunctive, an exception monad. I think exception monad will be will give you the distribution, but it's a special monad, the monad that has that interprets the Lax modality as implicit constraint implies the formula under some hidden condition. The formula will not distribute over disjunction, rather it distributes over conjunction. Anyway, so you can combine, yeah, you can, if you want, yes, make it stronger, but you don't have to accept distribution.
I see. Well, in general, thanks a lot. It's really fascinating, and I have lots of questions about the algebraic structure, but I suppose I have to choose. So if you take, for example, double impossibility, I mean, from this collapsed version, one would suggest that this behaves like some sort of box diamond or some sort of double negation. Is it true that its fixed points give you a classical behave like you have a classical translation or something like that?
A standard translation? No, you require algebra.
Yeah, I mean box diamond in the usual setting, so to say. Fixed points of a box diamond form a Boolean algebra in the algebraic context.
Yeah. Yes, true. Yeah, so I know that if you take intuitionistic negation with a diamond, intuitionistic negation of a diamond, in this here in CKD, the intuitionistically negated diamond would be such a modal operator, and such a possibly.
So what about double impossibility?
Double impossible.
Yes.
Yes, I don't know.
So in general, what kind of algebraic structure one gets? I mean, this is the first time in my life I have no idea what is the algebra. What is the algebraic structure?
Well, there's a nice story on algebra developed by I think Stanislav also, Odintsov for sure, on or who was it? Yeah, you know probably much better, no? These works where for the system N, which is a theory, but for this free theory of frames and a double quantified interpretation. Yeah, I don't know.
But probably you can answer this question about this double impossibility sort of easily on the particular example of Kripke structure
for all exists
that we have.
For all exists.
Here. Yeah.
So I mean, concerning double negation, there was a separate paper on double negation operator in the logic N star. There is an old paper by Sergei Derbyshevich from 2015 on that. So this was the whole problem of axiomatizing that stuff. I'm not sure about other settings like over N and what will happen in other logics, but that was not a trivial thing to do, right?
Mm-hmm. So can you repeat the name? Who was that?
There was a paper by Sergei Derbyshevich. You have already mentioned him, right?
Yeah, I mentioned that.
This is a paper from 2015, I guess. It's called
where he looks at negation operator.
It's called double negation operator in N star, right? So that paper was in Russian, but then it was translated into English, so it's not very well known, but there is one paper about that.
Mm-hmm. For using finite model property and finiteness of the structures. Now, yeah. Anyway, yes, that would be something I haven't looked at all. The algebraic setting, the algebraic import. No, yes. Mm-hmm. And maybe there's no. It's a double algebra of double negations, nested double negation, double quantifications, alternations. Mm-hmm.
Sorry, just one more question. You mentioned this redundancy and how one could restrict the class of frames and models. Could you say more about this? I mean, what kind of restrictions could you impose to still have constructive completeness and everything?
I think a lot, except if I don't assume even the fallibility. Having fallibility, well, I mean, what sort of restrictions are you thinking of? Like we can, the frames are reflexive, transitive. Yeah,
but on R you don't have any. It seems you don't have any conditions on R at all, right? R can be any relation whatsoever. Could you restrict it somehow to still have everything?
Yeah, we can. There's a lot of things. Let me bring some of the results.
So the idea maybe is that as with any modal logic, you put restrictions on R and you get versions of that modal logic in this constructive setting, so to say.
Basically,
S4,
yes.
transitivity, and so on, so on, so on.
Yeah.
So you presumably you get something you would call now the constructive modal logic of this sort, in full blown, in full square of Došen modalities. So
yeah, so we could. This is called would be a correspondence theory, where you study axioms as restrictions, no, second order conditions on the frames, and then try to have semantic and proof theoretic completeness results for these things. So that's interesting here because of the double quantification. The correspondence theory is non-trivial, and I'm not even sure. I mean, you will expect that these frame conditions, formulas you come up with, restrict the frames. There will not be first order conditions on the frame, but never mind, maybe second order conditions. So what I can say here is that, for instance, if so what we know is that if you take these axioms, for instance, take the CKD distribution axiom of diamond over disjunction. Do you see the slides?
Yes, yes.
Yeah. So if you take this, if you say my frames satisfy this second order condition, which is codified in that distribution axiom, so axiomatic frame class, then you get the Vizichera system, and distribution over disjunction of diamond is, well, is a kind of a confluence property on the frame, but I don't think it's a first order property. Just confluence of the frame. If the R and the intuitionistic relation are confluent, then you get the distribution axiom. But this is not. This is sufficient, but not a necessary first order frame condition. But as long as we are not worried about first order, second order frame conditions, that's what I can say. So take that class of frames that satisfy the distribution axiom, you get the Vizichera system. If you take both distribution axioms, you get, of course, the HK diamond. If you take the distribution axioms and you add the IK5 axiom that I've shown before, which is a frame condition, in our frames, maybe not a first order frame condition anymore, but a first order frame condition in the old interpretation, you get IK, the Fisher-Service system from 1980, 81, 82. If you take the axioms that Borzig and Došen have used, you get their combination. If you take some of the, here's the N system. If you take the distribution of impossibility, the binary distribution of impossibility over conjunction, creating a disjunction, and the two distributions and two further distributions. Take the distribution of impossibility over conjunction, which is innocuous, and take two distribution axioms, new ones, that make the impossible distribute also over conjunction in the binary and in the nullary case. Then you have this theory of negation, where you can treat the impossibility as a negation operator, and the system, this is a frame class in our setting. No? So there's a certain class of frames will give you n star, with negation being impossible. Or you can play it. You can generate the negation of n star from the unnecessary modality. If you make the unnecessary, if you look at frames where the unnecessary distributes not only in where the unnecessary distributes in both ways. In the D and N are the two distributions of unnecessary over conjunction creating disjunctions. If you take these frame class, then you get n star as well. But I don't know more. That's all. You can continue to, depends what logic you want. You can look at first order properties and then study, see if you can render these first order properties into formulas and then have completeness. But this is getting interesting because I don't think this is the double negation, the double quantification breaks these general results of normal model logics, like Sahlqvist formulas, always being first order properties, generating frame classes that can be finally axiomatized, final model property, etc., etc. All these general results go down impossible, or do not hold in the form that they have been proven. Yet need to be reproven, maybe for classes of second order properties that we don't know yet. Haven't looked at. So it's a playground. I think it would be an interesting playground for algebraicists to see what also model theoreticians, first order, model theory, second order, the bridge between first and second order.
Just one more short question. Sorry. In this example you showed, I understood that it's essential. You cannot touch the intuitionistic relation. For example, you can't require it to be antisymmetric, right? But if you still do it, what kind of disasters would you get?
if you force antisymmetry, you lose finite model property.
But you still have some.
That's already a second question.
Okay. Okay.
Okay. Ask it.
No, I already asked it.
Okay.
I don't.
Okay, it's really time for us to stop.
Okay.
Let us thank the speaker for this.
Thank you all.